In lesson 4 or 5, we get to learn 2 more ways to prove triangle congruence: the angle-side-angle postulate and the angle-angle-side theorem. The angle-side-angle congruence postulate states that if 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another triangle, then the triangles are congruent. And that's abbreviated angle-side-angle. So again, included means it has to be between the 2 angles. The first example is of a paragraph proof. They gave us that L is the midpoint of WE, so those two would be congruent, and WR is parallel to ED. So that means our alternate interior angles are going to be congruent. So that's kind of giving us a little proof outline, so we have a plan. So they want us to prove that the 2 triangles are congruent. We can see on the diagram that we're also going to have those vertical angles congruent there as well. So I would have started the proof with, we are given that L is the midpoint of WE and WR is parallel to ED. And then we could state angle W is congruent to angle E because alternate interior angles are congruent. And by the midpoint theorem, WL is congruent to EL. Since vertical angles are congruent, WLR is congruent to angle ELD. So our triangles, WRL is congruent to triangle EDL by angle-side-angle. We had enough parts in that last proof that we could have also proved it by angle-angle-side congruence. So if 2 angles in a non-included side of one triangle are congruent to the corresponding 2 angles and side of a second triangle, then the 2 angles are congruent. And that's abbreviated angle-angle-side, so AAS. Now I'm kind of liking the flow proofs. They gave us 2 triangles that overlap, and so we've got angle NKL is congruent to angle NJM, and KL, mark that there, is congruent to JM. And they want us to prove that LN is congruent to MN. Okay, so if we drew our 2 triangles separately, it might be easier to see. So these 2 triangles have a shared angle. Angle N is the same on both of them. Okay, now that we have a plan, we can do our flow proof. So we have our given, and angle N is congruent to itself by reflexive. So triangle JNM is congruent to triangle KNJ by angle-angle-side, because it's 2 angles in the non-included side. And then our favorite theorem, we can say corresponding parts of congruent triangles are congruent, so our parts, segment LN is congruent to segment MN. So you should already have these 4 methods of triangle congruence in your notes, either side, 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 all 3 sides are congruent, side, angle, side, a side included angle on the other side, angle, side, angle, so an angle included side, another angle, are angle, angle, side. So 2 angles and a non-included side. Okay, this is a little bit goofy. When Ms. Gomez puts her hands on her hips, she forms 2 triangles with her upper body and arms. Suppose her arm lengths AB and DE each measure 9 inches. Yes, her arms are the same length, that's good. And AC and EF both equal 11 inches. Also suppose that you're given that BC, her torso, equals DF. Determine whether triangle ABC is congruent to triangle EDF. Justify your answer. Well, it is, because they gave us side, side, side. So the 2 new ways of proving triangles in this lesson were angle, side, angle, and angle, angle, side. If 2 pairs of corresponding angles in the included sides of triangles are congruent, then the triangles are congruent. And if 2 pairs of corresponding angles and a pair of corresponding non-included sides of 2 triangles are congruent, then the triangles are congruent.